Okay, I am going to look at this power curve right here. And what I've done here is I've created a new tab, and essentially I've manually inputted some values just by approximating at each wind speed what the approximate output is. And I'm just kind of going to recreate this plot in Excel so that I can then fit an equation to it that I can then plug my wind speeds into to get a power output. Okay, so I've input those values again just by approximating, looking at that plot there. And what I'm going to do here is I'm just going to insert a scatter plot. Okay, and you see that I've essentially recreated the uh, the chart that I had over here. And what I want to do, again, is fit a curve to it. And again, I know what's going on below 3. I know what's going on above 14, and I'm going to force the issue on that. But at this point, what I want to do is I want to fit a curve into those intermediate ones. And again, uh, I'll force the issue above and below this. Okay, so I'm going to go ahead and right click on here, and I'm going to add a trend line. And what I'm going to do is I'm going to add a polynomial. These other trend lines are not going to be good. Okay, and even with the polynomial, I need to kind of increase the order. Again, recognize I don't care what the plot is going to do beyond my range here, because again, I'm going to force the issue. Okay, so this one looks pretty good, but I think I can do a little bit better. Okay, and there we go. Fifth order looks pretty good for me. It might be different for what values you put in there, but this looks like a pretty good approximation of what I've got going on here. So what I'm going to do here is I need that equation because I want to use that equation. I'll put the r squared value up there just because it never hurts to have it up there. Okay, so this is an equation where basically my y value, okay, is my power output, and my x value is the wind speed. And I'm going to use that with my data to figure out how much wind speed is being put out. Okay, so I'm going to come up here and copy this guy. I'm going to head over to my wind speed here, and I'm going to paste this guy right here. Okay, and you see I get this equation, okay, that I have in there. I'm going to have to manipulate this, but first let me say, okay, this is my Vestas, which is kilowatt hours. You're going to do this for all of the different windmills that I've given you. So I'll label this one Vestas, put kilowatt, not, did I say kilowatt hours? I mean kilowatts, which is the output, okay? And again, this is going to be the equation. Y is my output, okay? So I'm going to get rid of that. And what I need to do here is I need to put a multiplication sign and a power sign everywhere I have X, okay? Because I'm multiplying times X to some power. That's, and then when I just copied it, it doesn't put that stuff in there. So multiplication to the power, multiplication to the power 3, multiplication squared, and then this one is just multiplication. Now, of course, I don't want X. Instead of X, I want my wind speed. So I'm going to come over here, grab my wind speed. So everywhere I see X, I'm going to grab the H2. Like so. And what I do here is now it plugs in H2 everywhere that there was an X. So for 7.6 wind speed, I get 932. Coming over here and checking it out, so 7.6 is, I don't know, right about here. I come up here, you can see, hey, yeah, 900. Yeah, that seems about reasonable. Again, it's tough to tell, but that seems like about where that line should be. Okay, it gives me a good value of the output that I'm getting from my windmill. Okay, so I'm going to go ahead and copy this all down. Now that I've got that done, I'm going to come in here and uh, I'm going to filter this out so I can see what my values are. Okay, and you see I have all these weird negative values. Okay, and I have also got some larger values, right? I know the maximum is 2600, right? And that's basically because the equation falls apart below 3, falls apart above 14. Okay, and what I need to do is kind of force the issue here. Okay, so what I think I'll do is I'll scroll down till I see. So here's a negative value right here. Okay, and you can see this is at 2.2 meters per second. That should be 0. I want to force the issue, and I'm going to do that using an if statement. Okay, so in here I'm going to say, okay, if this value H56 that I have here, if it's less than 3, then make it 0. Otherwise, hey, go ahead and use this equation that I've got here. Okay, so it only applies the equation if it's above 3. Anything below 3 forces it to 0. Again, that's called a cut-in speed for our windmill. So you can see now this will be 0. And you'll see as I fill upward, none of those values change. Okay, as I fill downward, okay, we get some 0 values going through here. So again, I need to do that because again, that equation is only good between 3 and 14. So similarly, what I need to do is I need to do kind of an upper bound as well, because those higher values, right? I don't have any of those weird negative values anymore, but I still have those ones that are bigger than 2600. That's what's going on after 14. So I need to kind of nest my if statements here and say, okay, well, if it's less than 3, make it 0. Otherwise, if this value H2, if it's greater than 14, then force it to be 2600. Otherwise, do the equation. And I've nested this, so I need a parenthesis on the other side. Okay, so again, what I've done is I've nested this. If it's less than 3, make it 0. If it's greater than 14, make it 2600. Otherwise, if it's between 3 and 14, do this equation that I have here. Okay, and you see it doesn't change the value there. Autofill that down, and you'll see now those higher values have gone away. Peaks out at 2600. So all of my values now make sense between 0 and 2600. It applies that equation at those points that I have there. So that's how I figure out the power output of my equations here. Let me quickly see how long this video is going, see how much more time I want to spend. I've got time. So what I'm going to do now is I think I'm actually, let me turn off my filters. Okay, because what power is one thing. Okay, what I need is energy, which is kilowatt hours. So what I need to do is I need to figure out, I need to take this value by the number of hours that that wind speed is being applied. Okay, so what I'm going to do here is I'm going to create a value called duration, okay, which will be in hours. Okay, and basically it's, you know, I'm getting this more or less hourly wind data, and I want to figure out exactly how many hours has been since the last value. And what I'll do is I'll assume that the wind is about that the whole hour or the whole time in between these values. Okay, so I need to deal with these values here, these times. Okay, so what I'm going to do is it's basically a series of equations, right? I'm going to take my current hour and I'm going to subtract it from the previous hour. Okay, so that's been 1 hour. Okay, but you'll see as I throw this down, right, this value here, okay, going from 234 to 1, you know what I'm saying, I'm sorry, 234 to 254, okay, yeah, that's 0, that's been 0 hours. So I need to account for those minutes, okay? So what I think I'll do here is I will add the change in minutes divided by 60. So that'll be this minute minus this minute divided by 60, okay? And we'll autofill this down, okay? So then you'll see right here, okay, I'm going from 1254 to 154. That's 1 hour. Here I'm going from 154 to 234. That's 40 minutes, which is 2/3 of an hour. Okay, so this is what's giving me my duration that I have here. Okay, so, and you might be wondering, hey, why didn't you do the top one? Well, the top one is a little different, right? Because I don't have that previous value. So what I'm going to do here is I'm just going to take this time divided by 60 that one's gone for 54 minutes. I'm going to use that 54 minutes as the first duration, right? I'll assume that this thing started at midnight and go up to that time, okay? So that's where that value comes from. Now, let's do the same sort of thing where I do some filtering here, okay? And see what, well, I've got some weird value. I've got these negative 23 values, okay? And what's happening here is, well, let me just select one of them, okay? And you'll quickly see what's going on here. What's happening here is, it's tough to see that way. Let me explain what's happening. Basically, what's happening there is we're going to the next day, okay? So let me scroll down to the first time the day changes, and you'll see right here. I get a negative 23 hours because I've gone from 12 or 11:54 to 12:54. That gives me a negative 23. Okay, so basically what I'm going to do is I'm going to say, okay, I'll do another if statement. That'll probably be the easiest way to do this, and say, okay, well, if the day is the same, so if this equals this, okay, then do what I did, okay? If it's not, that means the day has moved forward a day, okay? The day has moved forward a day, and what we have then is I want to do the same thing, but I want to add 24 hours to it. Because basically I need to account for, so I just copy and paste, and then I'm going to do a plus 24, okay? Because again, I have that day change. And, rather than going from, 2,300 hours down to 0 hours, I need to account for that, saying, no, I'm actually adding a day, so plus 24 in the number of hours. And you'll see in this value, it doesn't make any difference. All of these values should stay the same. It just changes when I go from day 1 to day 2, and now you see I have 1 hour. Okay, so that takes care of that. Okay, now when I look and see, okay, I don't have any weird negative signs. I do have some big ones here. So but let me show you what's going on say like this 10-hour one. Oops. Okay, so we'll deselect all of these. We'll see where this 10-hour is occurring. And it is, that would be June 1st. Okay, so now I have to undo this. And let's go see what's going on June 1st. Okay, so I need to scroll down probably about halfway or so. So you can see here, there's the 10 hours right there. Okay, and we can see what actually is happening is, hey, that is because it's at 2:54 p.m. one day, goes to the next day, and I'm at 12:54 a.m. That is actually 10 hours. So I think we're okay here. We do need to account for the change in day, and that's just that, hey, check to see if it's the same day. Otherwise, hey, we've gone to the next day, and we can just add 24 hours to it, like I have done right there. So that gives me the duration. That's the duration that's the time between points in hours. Because now what I can do is I can now calculate the Vestas kilowatt hours, because this is how much energy it's actually putting out. Okay, so maybe call this one, let me undo my filters here. Okay, and I'll call this one Vestas power in kilowatt hours, and I'll call this one Vestas energy in kilowatt hours. Okay, powers in kilowatts, this is in kilowatt hours. Okay, and all a kilowatt hour is that power, kilowatts, times the number of hours that it's occurring, which again, we've calculated by using that time value that we've got there. So this puts out over this 0.9 hours, 839 kilowatt hours of energy. Drop that down, and what I have now is all the energy produced over the entire year. okay? And what I can do then is I can come down to the bottom, okay? And I can add this up, and this is the total energy that the Vestas puts out each year, okay? And let me just do it this way. It'll be a lot easier. Okay. Um, and I'll just force this to be 2 rather than highlighting 12,000 values. So I'm summing up all of the energy produced, and you can see that this guy puts out, what is that, 1 million kilowatt hours of energy over the course of the year, which is what we're trying to find out. So I'm going to stop here. Let me just rehash. I took the power curve, plugged it in to get an equation. I then used that equation along with some if statements for the cut in and the cut out speed to figure out for each wind speed that I have, how much power is being produced. I then figured out the time in between values to approximate how much time, the amount of time that the wind has been producing that much speed. So I get that in hours. Once I get that, I can take the power produced times the number of hours between measurements to get the kilowatt hours of energy put out. At that point, I can sum them up and figure out how much power is being produced over the course of the year by this windmill itself.